Okay, so realistically, this is just extending on what I just showed the whole video. You guys be able to solve any sort of trig problem. I would say there's two main ways that I ask you to solve something. I could give you this. I could say sine of 30 degrees and say, what does it equal? Just, yeah, those not been there, would you? Just in the normal one. Yeah, either one's fine. Now, if I tell you that sine of 30 equals something, how many possible answers are there if I give you one? If I give you the angle, there's one location for this to be. You then say, well, sine of 30 means that it's in, like, say, this quadrant here. 30 degrees means this is like a 1, a 2, or root 3. So you'd say it's 1 over 2. It's a fraction. However, let's say I gave you the exact opposite. Let's say that I told you the sine of an unknown angle equals 1/2. Now how many answers are there? At least 2. 2 just within going around a circle once. Realistically, there's an infinite number of answers. And another way that I can show you that is by going back to what we learned in one of our last lessons about what the sine graph looks like. It's been a while, but this right, what's a good one? Okay, I don't have a good one. Here, I know this says cosine, but you guys remember doing a sine graph the other day where we made our little manipulative here? Here's a basic sine graph. If I were to ask you where it equals a half, 1/2 would be like, say, up straight across the line right about here. Well, look, there's an answer right here at 30 degrees. But is that the only answer that it will be? No, it's one of many answers. You'll have another answer over here at 150 degrees. You'll have another answer over here at 390 degrees. Another one at 420. That makes sense? So in one direction, if I give you the angle and ask for the ratio, there is just one answer. Whereas if I give you the ratio and ask you for the angle, there's many answers. Is everybody okay with that concept there? Let me find my slide again here. So to me, then there's three main ways you can try to solve something. And I just want to kind of give you a ton of diploma questions to practice. The first way is you try to solve it like algebraically, where you use things like your cast rule, you draw it out like on a grid like this, and you use those sorts of general skills. Second option, use it graphically. If you were to say, well, I need where sine of theta equals 1/2, then make sine x one equation, make 1/2 the other equation, and intersect them finally across. That could work too. Or the third answer, by the way, this is probably your best bet to start with. If it is multiple choice, take the 4 answers and plug them into the equation and figure out what works. That's the fastest. But if it's not multiple choice, you can't do that. You know what I'm saying? So I want to try just a couple of generic questions that I wrote, and then I got a ton of diploma questions to try. So this didn't format very nicely. If you guys can't see that, that's sine of theta, tan of theta equals 1, and then it's between 0 and 360. So here's one way of solving it. If I'm asking you where tan of x equals 1, that's really 1 over 1. That makes sense? Like 1 is 1 over 1. What sort of triangle needs a 1 over 1? Yeah, the 45, right? So if I draw the triangle out in this quadrant right here, 1, 1, root 2, means it's 45. There, I have an answer. 45 degrees is one of my answers. There literally is no more work to it than that. Like, you just kind of know it, I guess. And that's what the grade 11s have to be able to do right now. What I'm making them do that's extra is I want them to be able to recognize there's an extra answer in this quadrant over here. They don't necessarily know this, but like where they're supposed to stop is they're just supposed to know that there is another quadrant. And that's why I find it to be a very arbitrary stopping point. But like all you're going to do is just say, well, this is 45 degrees, then the other answer is 215, because you just add it to 225 degrees, because you add it to 180. Which is what I'm having them do, which is beyond their scope, but like it's like one extra step. Does that make sense? There, you have your two answers. 45 and 225. That's one way of solving it. Second way of solving it, you could go and graph this thing. So you go y equals tan of x. Figure out where tan of x is going to equal 1. You're probably going to want to change your graph scope a little bit here. So like, let's make sure that we're in degrees. Let's make your window, actually this isn't bad. We'll go from 0 to 360, negative 10 to 10. Here's what a tan graph looks like. It's been a while since we talked about this, but do you guys recall how last week I showed you what a tan graph looks like right at the end of class? It basically goes asymptote, 0, asymptote, 0. We just finished with this last week. Tan looks like this is what a tan graph looks like. Basically, there's a 0, then it swoops up for an asymptote. Then it comes back through 0, swoops up for an asymptote. Anyways, all we have to do then is figure out what that equals 1. So we go second, calculate the intersect value. Here I found one. I'm at 225. And I mean, if you really took the time to, I'm sure you guys can find the other one at 45. Does that make sense? So that's a tool you have in your Batman utility belt of options for how to solve things. 1, you use like a unit circle. 2, you graph it. A third option. This one's a little risky, which is why I don't usually recommend it to kids, but you could always go inverse tan of 1. The reason why I find this one risky, though, is it gives you one answer. Does that make sense? As soon as you inverse tan of 1, it gives you one answer, but hopefully what I've seen in your head is that there are many answers, so don't just stop and do that. Does that make sense? Okay, let's try another one. If I were to ask you for this one right here, cosine of 3x equals 0.5. One option would be to say, well, ignore the 3x, just where is cosine equal to 1 over 2? And if you know your triangles, 1, 2, and root 3 is one of the triangles. So if I were to plot that out, the adjacent is 1, the hypotenuse is 2, the opposite would be root 3. What angle would go in that corner? Yeah, this one's a 60 degree. But here's the problem then. If I say that theta was 60 degrees, it wasn't actually theta, it was 3x is 60 degrees. So then, how do I get what x actually happens to be? Yeah, it's going to be 20 degrees. All you're going to do is take your answer, and when you're done, divide it by theta. Okay, but how many answers will there be? Yeah, there's actually going to be 6 answers. And then once you figure out the pattern to this, is there another location this could be? It also could work down in this quadrant right here. It would be 2 and negative root 3. But it would still work, that would be 300 degrees. So if you went all the way around to 300 degrees, that would work, but then you have to divide by 3, so 100 is your next answer. Now, normally that would be it. Normally you'd get a 60, you'd get a 300, you'd divide by 3, you'd call it quits. But I think, Rebecca, you're already ahead of me here. What's the next answer after that? Can you explain how you got that?
So you add 60 to 360 and then divide.
Yeah, because you can go around the circle again, right? What you could do is you could add 60 to 360, that would have been 420. Now, normally 420 would be outside of your parameters, but you have to divide by 3, and when you divide by 3, it now comes back inside your parameters of between, well, this is between 0 and 360. What did you get for? 220? No, I'm not dividing by 3 gives you 220. 420 divided by 3 is 140.
Oh, sorry.
140 is the next one?
Yeah.
Okay.
I'm sorry, I was skipping.
Okay. And then the next one would be 360 plus 300, which would be 760. That's probably the 240. 220, okay. You guys kind of get how this works though? Is you got to find the next one around the circle, which normally is too big for your parameters. And then once you find the one that's too big for your parameters, then when you divide by 3, then it works again. Now, I can also show you how to do that though by finding the graph of y equals cosine of 3x and finding where it equals 0.5. Before I graph this, what happens to a graph when you put a 3 in that location? What does it do to a graph? Yeah. So like everything gets squished in by 3 times as much when you put a 3 there, which means that when I look at my cosine graph, it goes up and down once, twice, 3 times. There's 3 of them in there, which means when I cross a line somewhere in there, and it's not a very good window size here. Let's go from like saying -1 to 1. Here's one cosine graph. Here's your second cosine graph. Here's your third cosine graph. Now when you cross the line at 1/2, how many answers are there? 1, 2, 3, 4, 5, 6. And if you wanted to, you could intersect for all 6 of them. You get the same thing. one last problem. This question though asks them to be between 0 and 2 pi. So you actually need to then convert everything into radians, which kind of sucks. So let me show you a nifty little trick though to help kind of speed things up here. Now, Rebecca, did you solve for all the other ones in degrees yet?
Radians.
Did you get them all in degrees by chance? Can you give me the other two in degrees?
260.
So I'm assuming you guys can all get those four answers in degrees. If you have to do it in radians though, here's a nifty trick. This was supposed to be a 60-degree triangle, and if you know your conversion, 60 degrees was supposed to be pi over 3. Supposed to be. Then you divided it by 3. So what happens when you take pi over 3 and you cut it by a third? Yeah, so this one will be pi over 9. Okay, then you're supposed to go all the way around the circle to 300. This would have been 1, 2, 3, 4, 5. 5. It would have been 5 pi over 3. But then when you divide it by 3, it's going to be 5 pi over 9. Then you were going to keep going around the circle. So this is going to be 1, 2, 3, 4, 5, 6. This would have been the 7th one. So it would have been 7 pi over 3. It now becomes 7 pi over 9. Then it would have been 7, 8, 9, 10, 11. It would have been 11 pi over 3. Now it becomes 11 pi over 9. One thing you notice is it's all divided by 9s now because it's 3. Does that make sense? You don't actually have to do this. Like if you really wanted to, you could go 340 degrees times by 2 pi divided by 360. Like you could do that if you wanted to. 340 times by 2 divided by 360. This is 17 pi over 9. You could do that if you really had to do it the long way. Yeah. Does that make sense to you guys as ways to solve it? Let's build it up a level. Those ones are very basic. The next thing they might give you is something a little more complicated like this. 4 sine x plus root 12 equals 0. It is the exact same thing, only you have some algebra to do first. The first thing you've got to do is do some like rearranging. For example, am I losing anybody if I do this? 4 sine equals negative root 12. I'm going to bring root 12 to the other side. Then I'm going to divide everything by 4, giving me sine of x equals negative 12 over 4. Then root 12, you can do some stuff like that. Root 12 can actually be broken up into a 3 and a 4. But the 4 square roots to give you a 2. So you can actually call it minus 2 root 3 over 4. Then I can cancel the 2 and the 4, and it actually gives me negative root 3 over 2. So it took a little bit of algebra work to manipulate it to that point, but now it's back to being really straightforward, right? Where is sine equal to negative root 3 over 2? Well, sine is negative in this quadrant here. It's also negative in this quadrant here. We just know what angle that is. Yeah, that's what 60 is, right? Okay. So then, just a little bit of 360 and 180 math. I believe the angles are going to be 300 degrees and 240 degrees. Or whatever their doppelgangers are in radians. Depending on which one I use. That makes sense?
The answer is like plus minus 360.
Yeah, if I ask you for a general solution, then you gotta add or minus 360.
Is that only if you ask for a general?
Yeah, only if I ask for a general solution. I mean, I guess, yeah, I would do this, plus or minus 360 degrees n, something like that if it's a general solution. Otherwise, if I give you parameters, and I say find all of the angles between 0 and 360, those are the two. Sometimes what it'll do is it'll say only find the angles in quadrant 3. And so if it says only find the angles in quadrant 3, then you'd only pick the 240. Okay, the next one, this is usually the step where a lot of kids get lost. Because now it looks intense. It is. I mean, it's a little bit different here in terms of how this works. So, now, don't forget though, you have another option in your Batman utility belt. Graph it. Don't forget that is an option. Not everything is designed to be easily solved using some sort of algebraic technique. I bet you I can find a way to solve it using algebra, but this is way easier. You go sine x, cos x, add sine x, add cos x, and then tell me where that is equal to negative 1. So I graph it. I get this right here. I don't know if you guys get something similar here. It gives me some sort of really funky looking graph, almost like a W it looks like. You guys get that too? For window size, by the way, I was on 0 to 360, and I was on -1 and 1 for my window size. So 0 to 360, -1 and 1, and when I graph it, I don't know if you guys can kind of see the same thing here. Here's what the graph looks like. How many answers am I expecting? Probably 2, yeah. One of them intersects right there, and one of them intersects right there. All you gotta do is just intersect one. So I can calculate the intersect. I'm just gonna FLIL away. Okay, so one of them was at 180. The other one. I guess 210, 270. Still thinking. Did you guys get the second one intersected? Oh, there we go. Now it finally showed up 270. Does that make sense? So the reason why I put the slide on right here is that sometimes I think kids, they get expecting that they only ever have to do things like this in an algebraic method. Don't forget, you can just graph it and find where things intersect. That's valid. And sometimes the diploma questions are designed to encourage you to pick one method or the other. I'm sure that if we tried hard enough, we could find some sort of algebraic way to solve this. I'm sure there's a way. But that's not the point. You guys agree? Like the faster way of solving this is just graph it. You know what? I think I've probably covered enough. Why don't actually? Can I do A here, and then let's do some of those home questions. I think I should make a point on A. On this one right here, you could graph it. One of the problems though is how do you graph a cosine? Do you guys remember? No. Yeah, go sine x all to the -1. That would work. Okay. But I got another idea here. What you could do on this one here is make it 3 sine x plus 2 equals 4 over sine x. You guys know how like cosecant means it's the flipped reciprocal of sine. Now this may seem a little odd to you, but I'm going to then get rid of the sine x on the bottom of the fraction by multiplying it to the other side. And what it's going to do is it's going to make 3 sine squared x plus 2 sine x. It's going to equal 4. Essentially, I'm distributing it across both of these guys right here. And if I haven't shown you this before, sine squared x really means sine of x, and you're squaring the whole thing. But the reason why we write the sine squared x like this is you don't ever want to square the angle. Okay? The worst thing you could do would be to do the sine of, say, 30, and then square the angle. That's not what you're looking for. What you're looking for is what sine of 30 is, and then you square it. So as a way to like safeguard against accidentally squaring an angle, we write the squared sign right here. So the reason you might want to choose to do it this way is this is quadratic. What you basically have is 3x squared plus 2x minus 4 equals 0. And you can solve this using quadratic methods. We need numbers that add to give 2 and multiply to give minus 12. Ah, they don't even exist. Do they? 1 and 12, 2 and 6. Okay. So, although I had this great idea that I showed you this question to show you how you can make quadratic, you know what, I gotta be honest, at the end of the day, I think I actually just graphed this thing. If. It will be, but it will work. Does that make sense? You've already graphed it here? Yeah. If, do you guys get what I'm saying? No, if this factor, hypothetically, let's say it factors, and you end up with this 3x plus 2 bracket x minus 1, and then all you do is you say, well, then I need sine of theta to be negative 3 over 2. I need sine of theta to be 1. And then we just solve each of these independently. But that only works if it factors. Does that sound good? So instead, I would just graph it. Okay. So let's try some formal questions. So here's the first one. The lines y equals 1/2 intersects cos squared minus sine x twice over this interval. The question is, what equation could we use? The line y equals 1/2 intersects cosine squared minus sine x twice during this interval. What equation could we use to solve for x? Well, in a way, what they're saying is that y1 was 1/2, and y2 was cos squared minus sine x. So the equation really needs to make these two things equal each other. So like if you had cos squared x minus sine x equaling 1/2, is that one of the four equations? But, you know what, the trick I just showed you on the previous example would apply here. What if I were to take this 2 right here and times it to both sides of the side? You would then get 2 cos squared x. You'd have 2 sine x. If you subtracted 1 to the other side, it would equal 0. And I think that's one of the equations, isn't it? That's B. What'd you do, John? They didn't actually want us to solve it. They're just saying, if you were to solve it, how could you go about it? Here's another one. It's going to tell you that cotan of theta is negative 3 over 4. It also has this extra little random piece of information here. And then it wants what sine of theta is. You might notice it doesn't actually even care what the angle is. It just wants to know what sine of theta is. So here's where I'd start. I'd say, well, cotan is supposed to be the adjacent over the opposite. Cotan could be negative in this quadrant right here, where it could be negative 3 or positive 3. This would be a negative 3 and a 4 right here. Or it could also be in this quadrant right here, or it would be a negative 4 and a... I screwed that up though, didn't I? Yeah, I screwed that up. Sorry, let me fix all that. This should be the 3. That should be a negative 4. This should be a 3. That should be a positive 4. You guys will look. Okay, I made that mistake. You guys will see where I made it though. I did the wrong size. Do you guys know the other side of this triangle? It's a common triangle. It's 3, 4, and 5. Yeah, the way it works is that this is 9 when you square it. This is 16 when you square it. When you add it together, it gives you 25. When you square root 25, it gives you 5. 3, 4, and 5 is a really common triangle we'll use. So then, sine of theta, if it's in this quadrant right here, would be negative 4 over 5. But if it was in this quadrant right here, it would be 4 over 5. So I need to know which one is it. And that's where this comes in. This says that cosecant has to be less than 0. What does that mean? Yes, that's actually what they're applying for, is that cosecant is negative. What's cosecant supposed to be? Yeah. So we need to have a negative h over o. This quadrant right here would not have a negative h over o. So it was not this quadrant here. It must be this quadrant we're talking about, because this would be the only one that has a negative h over o. So then the answer is the negative 4 over 5. That's what it was equal to. This little piece of information here helps you narrow it down. It's their sneaky way of letting you know which quadrant to pick. Because there were two today. No, because it wanted to know what sign was. This is what helped us narrow it down. I get what you're saying here. But it actually wanted what sign was. One of the things that you guys are going to either love or hate about this section is that almost every question there's multiple ways of solving it. But sometimes like there's no work involved. Like it's very limited how much algebraic work you do. Like you could also try doing something like this in a calculator. Let's try another one here. This one's kind of like a puzzle. It's going to tell you that cosine of A is root 3 over 2. Right off the bat, we can solve all. Because I know where cosine of A is root 3 over 2. That's the adjacent over the hypotenuse, which makes this angle, that's the 60, this is the 30-degree one, isn't it? No, isn't that? Oh, yeah, that is the 30-degree one, yeah. That was 30 degrees there. Now, is that the only quadrant this could be? Well, no, it also could have been down here in this quadrant here, but you see how this little thing right here is a quantifier, kind of narrows it down for me? Although it could have been 330 degrees, or it could have been 330 degrees, we only want quadrant 1. So now I know that A is 30. Then B is 60 plus A. So if B is 60 plus A, then B must be 90. Logic. Then the last question is, well, what is secant of 90? So secant of 90, I can't actually work with that one quite as easily. Maybe I should go back to my graph here. Remember making our cosine manipulatives the other day? Here's what a cosine graph looks like. What happens at 90 degrees? This is 0. At 90 degrees, what's cosine? 0. Now secant is 1 divided by that. So since secant is 1 over cosine of 90 degrees, it's really 1 over 0. Can you do 1 over 0? Yeah, that's why it's undefined. I didn't really finish getting a chance to show you what these graphs look like all that much, so don't bother thinking in your notes, but I'll find them for you here. This right here was an example of a secant graph. If they ever give you a picture of a secant graph, it looks like this. It gives you like a U shape up here, then a U shape down here, then a U shape up here. Basically, it alternates positive and negative parabolas. And the reason why is that you're always going 1 divided by what your answer was. So like right here, you see how it got to the blue graph gets to a height of 1? Well, 1 divided by 1 is still 1. As these y values get smaller, these values get bigger. Until right here, when you get to 0. What's 1 divided by 0? Can't. Therefore, you have an asymptote. So like this right here is where 90 degrees would have been. This would be where 180 would be. This would be at 270. This would be at 360. So you actually, on a secant graph, you actually have asymptotes. Certain values you can't use. How many more do I have here? Let's try this. It gives you some graphs here.
Ken Bautista, please come to the office. Ken, please come to the office.
It gives you a graph, and it says that one of them is cosine x, one of them is cosine of 2x. What does that 2 do to the graph? Swishes in, yeah. 2 swishes in. 1/2 pulls it out. Oh. Now what it says here is that the graph intersects 4 times. You guys can see, right? It intersects right here, right here, right here, and right here. Now this one was really sneaky. They said, what happens if the domain is changed from 0 to x to 2 pi? And I made a note, what happens when the inequality gets removed? Are there more solutions, fewer solutions, the same number of solutions, or there's no change in the number of solutions, which is really interesting. You guys see the trick to this one? What's the answer? What happens if you remove the inequalities from this? How many solutions do you get? Well, this says you can include 0, and this says you can include 2 pi. These ones actually seem to intersect at 0 and 2 pi. So if I remove this one because it's not or equal to, and I removed this one right here, now how many solutions would there be? 2, which means there would be fewer solutions. That was really sneaky. Like, that's almost mean the way they're being sneaky on that one, because the only difference here is that this included the or equal to sign. You guys see that little sneak that they threw in there? And this one right here, they removed the inequality. Super, super cool. Okay, I want to show you a nifty solution for this one here. Here's one thing you could do. On this one right here, you could say, well, why don't I just solve for x? What this really means is that 10 of x all squared is 5 over 7. That's what that really means. So what you could do then is you could say, well, I'm going to get rid of the squared sign by square rooting both sides. So it means I need to have the root of 5 over 7. Right, I'm just going to square root both sides. Now, is this an exact value? Well, no. But can I still solve for x? Sure. Why don't I just do 10 inverse of the root of 5 over 7? That'll give me an angle. Now, it's not going to give me all of the angles, which is why I always hesitate to show you guys this, but that will give you an angle. So, I'm just going to put a calculator. Why don't I do it in degrees just to make it simple? If I inverse 10 root 5 over 7, I got an answer of 40.2 degrees. Can we get that if we try? Okay, well, then it wants to know what secant squared x is equal to. Well, secant is 1 over cosine. So all I'm going to do is put 40.2 degrees in there. I'm then going to square all of that after I'm done, and I'm going to put it on the bottom of the fraction. What I'm going to do actually is I'm going to do this. I'm going to do cosine of my answer. Then I'm going to square it, and then I'm going to go to the minus 1. You guys can kind of picture that. I'm just doing it all in one big swoop. This squares the entire thing. That takes care of the squared one. And the minus 1 turns it into the secant. Cosine answer squared to the minus 1 gives me this. You else get that? Then all I got to do is figure out which one of these it happens to be. Now I can try turning it into a fraction using my fraction button on the calculator. Oh, it did actually. It made it 12 over 7. If it was going to be C or D though, I would then take C and D, and I would just do it there as a decimal number, so they're the same as this one. Yeah, definitely gotta make sure you use the whole number, right? And then definitely.
McKinley or, can you please come to the office? McKinley or, please come to the office.
Okay, let me show you another strategy for solving this one. I mean, that one works, but there's other ways you can do this. For example, what is tan supposed to be equal to? Okay, now this is not tan yet, but at one point here I did tan, and I made it like root 5. What if I made it root 5 over root 7? Can you guys see how I'm kind of like square rooting everything here? It means that my opposite would be root 5, my adjacent would be root 7. So if I put that in this quadrant right here, my opposite is root 5, my adjacent is root 7. I should be able to figure out the other side. Because root 5 squared would be 5. Root 7 squared would be 7. Add them together, you get 12. Re-square root it, this should be root 12. Well, then it wants what secant is. Isn't secant supposed to be the function of cosine? So cosine is supposed to be adjacent over hypotenuse. I want that flipped, so I want hypotenuse over adjacent. My hypotenuse was root 12. My adjacent was root 7. But then it wants secant squared. So when you square it, you get 12 over 7. Yeah, sometimes I can show you like 3 different ways of solving things in trigonometry. One involving graphs, one involving like inversing to find angles, one involving guessing and checking, one involving using like just basic like putting on a grid kind of ideas. All of them work. your biggest issue now is trying to figure out what's the best way to solve the problem that's in front of you. Because some ways are better than others. What do I have? I have lots of questions here, don't I? I can't do them all. Let's just pick up some highlights. Let's do this one here. This would be a good one if you can find it. They want the general solution to 4x equals negative 1/2. Okay, if I gotta be honest, the fastest way of solving this, you guys check the 4x. All you have to do then is go sine of 4 times 7 pi over 24 and see whether it equals negative 1/2. Then you'd have to try it for this one here, and this one here, this one here, this one here. Like keep trying all the answers until you get one that works. That's pretty straightforward, right? Like just guess and check. Another possibility is ignore the 4x for a second here. Don't I know this 1 over 2 isn't that part of a triangle? Sine is negative 1/2 when it's in the opposite order. So like this quadrant here could give you negative 1, 2, that'd be root 3. Or it could be in this quadrant here. So now I found two quadrants coordinate. Okay, what angle is this? That's the 1, that's the 2. This is the 30-degree angle, I believe. You guys okay if I hop right to that 30-degree angle? Is that what you passed on? You guys know what 30 degrees is in terms of radians? It's pi over 6. Yeah, sometimes you'll pick those up over time. I actually happen to know it this way. Pi over 3 is 60, and pi over 6 is 30. And the way I remember it is that this one has a 3, so this one's a 6. And this one has a 6, so that one's a 3. The only reason why I want to suggest that is that if all the way around to here was a full unit, then this one here better be 7 pi over 6. And this one around to here would have been 11 pi over 6. That's what it would have been. Why am I saying that? Exactly, yeah, because this was 4, so all I gotta do is divide by 4. So 4x equals this. Really bring the 4 down to the bottom and make it over 24. So I need 7 pi over 24 and 11 pi over 24, which looks like it's C. Explain to me though the general solution part. Why is it not add or minus 2 pi? Why is it adding pi over 2? Okay, well, how far is it normally around a circle? It's normally 2 pi around the circle. But what do you do to all of your angles though? Dividing all your angles by 4. So what happens if you take 2 and divide by 4? You get a half. Which explains why these guys add half of pi. Is that clear? Normally your answer would have been 7 pi over 24 plus or minus 2 pi. This would be plus or minus 2 pi. But then when you're dividing everything by 4, well, when you divided this by 4, you got over 24. You got to divide this guy by 4 as well. And 2 over 4 is really 1/2. That's kind of what you have right here. Is this is half of pi. Oh. Let's find one more. We'll call it a day. Let's try this one. This is a very, very last one. Thoughts? You're being asked to solve for x. What are some of the ways we can solve for x? You literally could graph this. It'd be a pain because you have to type in secant 2x to minus 1. Sorry, you type in sine of 2x to minus 1. Divide by cosine of 2x to the minus 1. Then you have to make it equal to 5, root 5, and then intersect it. Well, like, that wouldn't work. Makes sense? Why don't we try that one first? So how do you type this in front? You can't type in cosecant, but you can type in sine of 2x. Then make it all go to the minus 1. You have to divide that by secant, that's cosine of 2x. make that go to the minus 1. And then all of this has to equal root 5. I should be in radians. I think it's clear that these answers are kind of referring to radians. If you guys see how this has got 3.14, that's pi. 1.57, by the way, is half of pi. So it looks like we should probably be in radians, which means I'm going to make my window size go as far as 2 pi, maybe. So if I do that, here's my graph. It looks like I got some asymptotes. Not a big deal. I'll live with that. And then root 5 is right. You know what? Actually, root 5 is on my graph. You know why? Root 5 is roughly 2 and a bit. But my graph only goes as high as 1. So I'm going to have to make my window size go as high as, say, 3. Now I should be able to get my graph. You guys get a similar graph? Mine draws in the asymptotes because it's an old version of the calculator. And then here, up here is root 5. I just got to find where it intersects. I just found a random intersection point. This one over here was 3.5, 3.35. I realize now that was actually a poor choice though. Really, which intersection point should I have found? Probably the very, very first one. Because really, if I find the very, very first one, wouldn't that be enough for me to know which answer it's going to be? Okay, so the very, very first one is at 0.21. So my first intersection point is at 2.2 and they're not this one here. Explain though why it's 1.57. Yeah, because what ends up happening is normally the period is supposed to be pi. That's the normal period of a tan graph, or of how this thing. Actually, I'm getting ahead. You guys don't actually know this tan yet. How about I look at it this way here? You guys see how there's 4 of them within here? It means that it repeated itself 4 times, which normally would be every 90 degrees. But 90 degrees in terms of radians is pi over 2. And pi over 2 is 1.57. If this is pi, this is half of pi. So like, here's the first one at half of pi. Here's a full pi. Here's 1.5 pi. Here's 2 pi. It kind of explains why the period is on like a every quarter of pi rotation. Okay, let me try one more way of solving this right here. What we could do is you could say it's 1 over sine of 2x divided by 1 over cosine of 2x equaling root 5. I could say that. I know that seems kind of dumb. But the reason why I would do that is now I can maybe bring this whole thing up to the side and make it 1 over sine of 2x equals root 5 over cosine of 2x. Like, I could like maybe rearrange it a little bit. And then I could cross multiply, which would give me cosine of 2x equals sine of 2x times by root 5. Now, I'm going to show you a trick that actually you haven't learned yet. I actually accidentally earlier in this question called it a tan. But this is actually the last thing I'm going to show you in next week's notes. If any of you guys have your formula sheets on you, there's actually a formula that says that cosine and sine are actually related to tan. This one's actually cotan. Joe, you have it in front of you. If you ever have cosine over sine, it's actually cotan. So what I could do is I could call this the cotan of 2x equals root 5. That's basically the way it works, is that cosine divided by sine is cotan. You see that one on the sheet? Okay. I'm going to do one more thing. I'm going to make it root 5 over 1 though. Here's why. What is cotan supposed to be equivalent to? Okay, I'm going to plot that. So the adjacent is root 5. The opposite is 1. I could find the opposite side of the triangle, but I actually really don't care. What I'm going to do is I'm going to inverse this and try to calculate the angle. So if cotan is equal to root 5 over 1, tan would be 1 over root 5. And if I were to inverse tan 1 over root 5, I could get myself an angle. All of that was just to get myself an angle. So I'll do it in radians still. I'm going to inverse tan 1 over root 5. And I got, I'm not in radians. I got 0.42. When I did that, I got like this. However, that's not the right answer because this was all about 2x being there. So then all I gotta do is divide that by 2. And now I get the answer. Now that though involved a trick that I haven't shown you yet, which is our last topic. You guys see all those? Joe, can I borrow your phone? The last thing I'm going to show you, there's a ton of rules on our formula sheet. We call them identities, where we can play little tricks and like change equations into other equations. That's what I'm going to show you guys in our last week, which I'm doing I think on Thursday. Yeah, it's our lesson on Thursday, and how you can use these to help you solve equations as well, if you know that cosine over sine is cotan. Okay, why don't I leave that there though? Let me go back to my very first slide and we'll call it a day here after this quick summary here. You guys are expected to be able to solve that equation. Okay. You have tools available to you. You can try to plot things on your axes. You can inverse sine, cosine, tan. It will give you an answer. It might not be all of them, but you can use that. You can graph and intersect. You can guess and check before answers. That makes sense? But like somewhere along the way, you're going to be asked to do some sort of solving, and that's a very broad term. So you can solve these many tools. Does that make sense? So if you have your assignment, the next one ready to go, it's actually a very, very short assignment. Have you guys actually printed it off yet? Here's the second assignment. I only have actually 3 questions on it because the bulk of it is I want you guys to start practicing solving some of these sorts of things right here. Like for example, in the first one, how would you go about solving something like this if you want to do it more algebraically? 6 cosine theta equals 3. Divided by 6, so then tell me where cosine equals 1/2. Right, that's one option. A second option would be to graph it and see where it intersects. This one right here, I'm going to highlight it there. I would find out where cosine is equal to -1. Once I find out when it's equal to -1, I take that answer and I divide it all by 2. Does that make sense? This one right here, you're going to need to factor. I tried doing one today, but it didn't actually factor nicely, but you're going to have to attempt to factor this. It's going to give you 2 cosine bracket.
Instructions to the following students, please come to the office. Krista Peters.
Anyways, that's kind of your next step then, is being able to solve things.
Austin Saunders. Ryan Servo.
Is there any questions?
And just an announcement for practices and game schedule for a few days. Tonight,
the end means you keep going
B girls are practicing from 3:30 to 5 at FP Walsh.
Yeah.
A girls are practicing from 5 to 6:30 at FP Walsh. Senior boys and girls, you're practicing at FP Walsh from 6:30 till 8.
That's the
Tomorrow, only the B girls and the A girls have a game.
Plus or minus, because an integer
Only the B girls and the B boys have a game.
If it doesn't say an I right here, it usually says like a natural.
And on Wednesday, A boys practice with the B boys from 3:30 to 5. So there's no A and B boys practice tonight, and the A boys do not have a game tomorrow.
Subtract from it, and the I just uses So the end just means you could then, the next time you want to find an answer, go all the way around the circle. Only you're not going all the way around the circle, you're going a quarter of the way around the circle. Okay. Questions? One less than actually done math.
Yeah.
So calculus.
Yeah. Okay. Oh, yeah, I'll stop the recording, I guess.